Good afternoon, everyone. So we just had our A-level H2 Math Paper 1 yesterday, and the comments I got was that it was a little bit harder than the past year 10 years series. Well, don't worry about that because that means Paper 2 might be easier, right? And, you know, we're gonna go through Diamond High, Paper 2, the stats portion today. And of course, if you want to score well, we need to capitalize on our stats marks. So, let's have a look at the questions today. Find the number of ways the letters of abductions can be arranged in a circle. The basically A, O, and U are not next to one another. Well, there are 10 letters, and you have 7 letters that you can arrange in any order. So we arrange the 7 letters in a circle with no restrictions first, which is 7 7 minus 1 factorial. So 7 minus 1 factorial. Then A, O, and U, we need to put each of these letters into one of the 7 separate components, right? Because if you draw the ring of 7 letters, there will be a gap, 7 gaps, and you can put A, O, and U into each of those gaps. So you do this times 7 choose 3, and of course you can arrange them in 3 factorial ways. So this will give you the answer, 151,200. A 5-letter code word is formed from Tyrannosaur. Find the number of code words can be formed if it contains at most one pair of identical letters. So if I just write down the letters, so let's see, we get A, N, N, O, R, R, S, T, U, Y. Okay. So there's 2 possible cases, is that they are all different. How many ways are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 types of letters. So you do 8 choose 5 times 5 factorial. This gives you 6,720. Then the case 2 is 1 repeated, right? 1 pair. Okay, so you choose, there are 3 possible pairs you can choose. So we take 3 times, there are 7 other types of letters, and you need to choose each of them exactly once. So you do 7 choose 4. Wait, no, 7 choose 3, because there's only 3 more letters to choose. 2 of them are the repeated letters already. And how many ways are there to arrange? Well, it's 5 factorial divided by the number repeated, which is 2 factorial. Okay. You'll get 6,300. So the total ways will be 13,020. Okay. 13,020. Find the probability that the code word contains both R and both N, given that it contains RAN. Okay, so it already contains one R and one N. So if we write down the new sample of letters, you will get ANORSTUY. Okay, so all we need to do is just, we already have 3 letters chosen. So in fact, the 5-letter code word, we must choose R and N, right? So there's only one way that you can do this. So that will be, yeah. So it will just be 1 over 8 choose 2. Okay, the order doesn't matter here, so we are not going to consider orders. It's just 1 over 8 choose 2, which is 1 over 28. Okay. Okay, commodity X is traded 4 times a week. Okay, so in a particular week, X rises on Monday and A and B are defined. A is the event that the unit price falls on Tuesday, and B is the unit price rises on Thursday. Okay. Find P, A intersect B. Okay. Oh, okay, I didn't write down my working for this. Okay, so there's a probability of 0.6 that it will rise on the next trading day. So if it falls, that means that it's 1 minus 0.6, right? So the first thing to write down is 0.4. Then, if it falls on a day, so we take this because on Monday it rises, so the probability it falls on Tuesday is 0.4. Now, if it falls on the next day is 0.15, that it will rise. Okay? So there's two possible cases. Either it will fall now and it will rise later. Well, I think I considered the case where it will rise first. 0.15. It will rise first, and it doesn't matter whether it falls or rises first as long as it rises on Thursday. So, uh, what's the probability in this case? It will be 0.6, right? If it rises, it will rise again with 0.6 probability, plus the probability that it falls but then rises, which is 0.85 times 0.15. Okay. This is 0.087. If you want, you can write down some workings to help you. Find the probability of B, just B, happening. I think I considered this by finding probability of A complement and B happening at the same time, which means that yes, I considered PA complement intersect B for this part. And I'll explain why in a bit. So what if the price falls? So what if the price actually rises on Tuesday? So there's a 0.6 probability, right? So now consider that it will rise on Thursday. So 0.6 and 0.6 plus the probability that it falls, 0.4 and then 0.15 that will rise, right? This is 0.252. Okay, but what is A complement intersect B? A complement intersect B is no, sorry, this one. A complement intersect B is this one, correct? So basically what I'm doing is I have found PA intersect B. So if I add this to PA intersect B, I will get PB itself, right? So this is A complement intersect B plus PA intersect B, okay? Which is 0.339. Okay. And finally, probability that B given event A. Okay. Now we need to find P B intersect A, which is the same as A intersect B, divided by P of A. So what is P of A? Well, it's 0.4, right? Yeah. So P B given A is P B intersect A divided by P of A. And PB intersect A is again 0.087 divided by P of A itself, which is 0.4. Which is 0.2175. So are A and B independent? Obviously not, right? Because if PB given A is equals to PB, then that would be the case. But we just need to write PB is 0.339. PB given A is 0.2175. Okay, not equal. So they are not independent. Okay. If the unit price of X rises 12 consecutive Mondays in a particular year, find the probability that it rises on exactly 5 of the corresponding Tuesdays. Alright, so I hope many of you realize that this is actually a binomial distribution. We're not going to calculate a conditional probability here because we are just given that it is 12 consecutive Mondays. We don't need to find the probability that it is 12 consecutive Mondays. Okay, so let T be the number of rising Tuesdays. Then T follows binomial 12 and 0.6. Because 0.6 is the probability that it will rise on Tuesday given that it has risen on Monday. So we are calculating P T equals to 5 here. Okay? Which is 0.101 to 3SF. Okay? So far so good. Okay. Correlation. The scatter diagram shows two different sets. Determine which set will result in a larger absolute value. Okay. Okay, I think this one is quite obvious. Or rather, just look at it. Absolute value of the correlation coefficient means that you take the modulus of R, okay? So which one is it going to be? Which one looks closer to a line, essentially? Well, it's going to be set B, right? Set B, as the points are closer to a line. Then set A lah. Okay? Okay. 8B part 1. Okay. You need to draw the scatter diagram. So same as usual. Make sure that you label your max and min. I'm just gonna tell you that I'm not gonna draw the whole thing because I think you guys know how to draw a scatter diagram. The scatter diagram looks something like that. Okay. This is 45, 47.9. Lower the lower and upper bounds for each axis. Okay, this is 45.5. X, this is Y. And then the highest point is 55.5 and 54. Okay. Try to get the scale right when you're doing your own version, but you know, I'm doing it roughly here lah. Okay. So the researchers will propose two models to represent the data. Which is the more appropriate model? Okay, so I assume that you guys know how to calculate the product moment correlation coefficients. You use your calculator, your GC, type L1 and L2. L3 you will set it to be the ln of L1, and L4 you set it to be e power half of L1. Then you compare L3 with L2 and L4 with L2 for the regression function on your GC, and you will get the respective R value to be 0.817 and 0.939. So obviously D is better, right? Because the value is closer to 1. The absolute value closer to 1, right? Okay. Use a regression line to obtain the estimate for the household expenditure for a household income of 50,000. Okay, and ask yourself, which regression line is this? Is there a clear independent or dependent? Well, here we can see that the household income is something that we can kind of fix, right, per person, and the household expenditure is what varies along with that. So we expect that to be the kind of variation. So we expect that y is what varies with x, and therefore we find the regression line of y on x. But it's actually y on e power half x. Okay, you will get y equals to 45.423092118 plus 8.535727.035 times 10 to the power of negative 12. Yes, I'm not joking. 10 to the power of negative 12 e power half x. Okay, and then you can sub in the value. To get the household income of 50,000, we have given that, so we find the expenditure. So y 50,000, and you will get 4, or rather no, you put 50 because the thing is measured in thousands. You will get 40.368. Okay, so therefore the estimate is $40,368. I think they will accept $40,400 also, because 3SF. So is this a reliable estimate? Well, 50 seems to be within the data range, right? And the correlation coefficient is close to 1. Within data range, so you're interpolating. And therefore it is reliable. Okay. Is it valid to conclude a higher income will result in a higher expenditure? Okay, this one is a very standard question. The answer is no. Hopefully you guys are aware of that. Correlation does not imply causation. This is something that pretty sure everybody has learned by now. A student claims that the product moment correlation coefficient remain the same between this half x and the power 20x. Is it true? Well, the answer is also no. Correlation coefficient only correlates y with e half x. So the correlation coefficient for y with e power 1 over 20x is different. Of course, you can also just calculate the r value using this new model, and you will also see that it's different now. Okay. A confectionery is selling mooncakes. Okay, this looks like hypotesting. Test at 10% significance. State an assumption. Okay, distribution is standard 6.73. Mean mass is 150 grams. So 9 mooncakes. Okay, so if you read the question carefully, they never said that the distribution is normal and the sample size is small. And therefore, we can already kind of foresee that the assumption will be that it will be normally distributed. The data is normally distributed. Okay. Assume mass of mooncake is normally distributed. Okay. Now, The sample mean, okay, I think you guys know how to calculate sample mean, right? It'll be 148. And we are given that the standard deviation is 6.73. And this distribution is a population standard deviation. So we don't calculate an unbiased estimate. We use it as is. Okay? So we define X bar to be... Actually, no, we should define a hypothesis first. When I wrote it out, I'm a bit lazy. Okay, so test H naught, mu is 150. Now, the owner claims that the mass is at least 150 grams. Now, technically, when you're doing hypo testing, you actually need to fix a certain number. So this question is a bit off, but never mind. I think the notion that they wanted to say is against H1. If they say it's at least 150, the alternative hypothesis is that it's less, right? So this is what significance level? So this is 10%. What is mu? Mu is the population mean mass of a mooncake. Okay, this is the population mean. Okay. On the other hand, X bar is the sample mean mass. Distribution X, or rather more accurately, X follows the distribution. How do I say this? No, I'm going to call this lower X. Is the sample mean mass. Okay, so you use the distribution under X bar is normal. We are under H naught. Under H naught, we are assuming that the mu is 150, so 150, and you take 6.73 square, divide by the sample size, which is 9. Then, of course, we standardize. You will get Z is X bar minus 150, divide by 6.73 divided by 3, which is normal 0, 1. Test statistic, you will get negative, I think, 0.89153. P-value, if you use your GC find p-value, is 0.186, which is greater than 0.1, right? So we do not reject H naught. And then conclude as per normal. Insufficient evidence at 5% or rather 10% significance level that the mean mass of a mooncake is less than 150 grams. Okay. And once again, the assumption that you need to make is that the distribution of the mooncake mass is normally distributed. Okay. So now particular countries, mean working hours is 60 hours. Home-based learning implemented. Ministry claims that the mean working hours remain unchanged. Random sample of 50 teachers was taken. Number of working hours recorded. The mean is 62 hours and K hours, but this is a sample mean and sample standard deviation, so we'll get to that in a bit. Conduct a hypo test, and it was found sufficient evidence to reject the ministry claim at 5% significance. Find the values of K. Okay, so take note that we need to use the unbiased estimate of population variance. Okay, which is n times n minus 1 times the sample standard, n over n minus 1 times sample variance, which is 50 over 49 k square, right? In this case, let x bar be the sample mean. Okay, I should define my hypothesis symbols again, but let me do that in a bit. Working hours per week. Test H0 against H1. Okay, so the ministry claims that mu is 60 and H1 claims that the timing increased, right? And we will choose mu greater than 60 because of the fact that our sample mean is greater than 60. Mu is the population mean weekly work hours. Okay, so now we have everything defined. So under H0, okay, so notice that we actually have a sample size of 50. So central limit theorem applies even though it's not normally distributed as stated. So by CLT, x bar follows the normal distribution with mean 60 as under H0, always the fixed number, divide by, okay, 50 over 49 k square, but you divide by the sample size 50, so you get k square over 49. Okay, approximately. Standardize, z is x bar minus 60, divide by the sample standard deviation, so k over 7, follows normal, 0, 1. Okay, so we need, so if you want to reject so now if you test statistic, if you put in 62, you will get 14 over k, I believe. Because you are doing a 5% test, one tail test, your z value needs to be greater than 1.9600. I think that's the 5% level. Oh, I just realized something. I think this is a two-tail test. Because reject that it is 60 hours per week. Okay, sorry about that. There's a two-tail test. Okay. And because it's a two-tail test, 1.96 is actually the 97.5 Z point critical value. I think that's why I wrote 1.96 here. Okay. So we need 14 over K. We need this to be greater than 1.9600. You will get K less than 7.14. So the set of values will be K, E, and of course the standard deviation has to be more than 0, so it will be 0 and 7.14. Okay, yeah. Okay, that's that. Question 10, okay, normal distribution. Okay. Sketch the distribution of x for masses between 558 to 646. You'll realize that this is actually 558 is one standard deviation from the mean, and 646 is 3 standard deviations from the mean. So these were not actually arbitrarily chosen values. So this is 580. This is 558. And this is 646. Okay. So it will peak here. And it will go towards 0 here. And it will also go towards here. Okay. Something like that. If I can get the curve down correctly. Okay. Yeah. So this will be the distribution. X normal 558, oh no, 580 and 22 square, which is 484. Okay. Find the expected number of rock melons with mass more than 600 grams from 300 randomly chosen. So that is just 300. So that will just be 300 P Y greater than 600, right? Where Y is normal, 870. Actually no, it's X, sorry. Because X is rock melon, Y is watermelon. X is normal, 580 and 484. Okay, and you will get 54.5 to 3SF. Now expectation is just a number, so no need to round off. Comment whether the combined masses will be, both types will be normally distributed. So I think this is kind of intuitive, but the answer is no. Distribution will be asymmetrical. Because the standard deviations are different, so you will kind of get it be closer to, so the mean would be closer to like what, 700, and you will get a mean that's like closer to 725, but like it will be skewed slightly because of the differences in the standard deviations. Okay, and of course one of the property of normal distribution is it has to be symmetrical. Rock melons and watermelons are $3 per kilogram and $2.80 per kilogram. Find the probability the mean selling price of 4 randomly chosen rock melons differs from the selling price of a randomly chosen watermelon by at most 60 cents. Okay. So let R and W be the price of randomly chosen rock melon and watermelon respectively, right? So what are the distributions of R and W? R follows the normal distribution, and you will get the mean mass is 580, so 0.58 kilograms times 3. So you'll get R is normal 1.74. The variance will be 20. So this is in grams, so you need to convert this to 0.022, and you need to multiply this by sorry, and you need to multiply this by 3, multiply the standard deviation by 3, because you converted to kg, then you need to square the whole thing. So you will get 0.066 squared, and I'm going to leave it as that because when you use GC, of course you enter the standard deviation. And similarly, watermelons follow the distribution normal. 870, you convert to 0.87, then you times 2.8, you will get 2.436. Same thing with the standard deviation, 0.03 kg times 2.8, and then square the whole thing. So you will get 0.084 square. So mean selling price of 4 randomly chosen rock melons So the difference, let D be the required difference. D follows normal. The mean will be 2.436 minus 1.74. Actually, no. Well, it doesn't matter. If I'm taking the modulus, it doesn't matter. So 4 randomly chosen rock melons, so 1.74 minus 2.436, you will get minus 0.696. And the variance will be, you take 0.066 square divided by 4 plus 0.084 square, right? And this gives you 0.008145. Then what you need to do is find P. Now it differs by at most 60 cents, so negative 0.6 less than or equals to D less than or equals to 0.6. Okay, so this will give you the required probability, which is 0.144. Arc 1 buys 20 melons and are rock melons and the rest watermelons. Find the greatest value of n, probably total cost of 20 melons exceeding $38 is more than 0.95. Okay. So, oh my god. Okay. Let T be the total cost. Okay, this one I'm actually going to show you how to get it. So T follows the normal distribution. Normal. Okay, bear with me. We take 1.74 because that's the mean price of a rock melon. Then we N. Then there's 20 minus N watermelons. So you take the mean price of a watermelon, which is 2.436, multiply by 20 minus N. Okay? And what is the variance? Well, you take 0.066 square, then multiply by N. This is the variance of the price of a rock melon plus 0.084 square, 20 minus N. And you don't square the quantities because you are taking independent observations, not like actually scaling the values by that much. That's the difference. So leave it at that. And you can simplify this if you want. This is normal. 48.72 minus 0.696 N. And variance will be 0.1412 minus 0.0027 N. Yep. Okay. Then using GC, you can find the probabilities required. So we want so this is the total cost. So we want N and the probability that T is greater than 38 for this value of N. We write down the values of 14 and 15. You'll get here 0.99880, which is definitely greater than 0.95, and 15 is 0.81130. Okay, and in fact 16 already drops to 0.091857, which is less than 10%. So you can see how quickly these kind of things drop now. Okay, so therefore the greatest N will be 14. Okay, yeah. Okay, finally we come to DRV. Wow, I actually did this quite fast. Okay, Emma is a computer program. We have A over R cubed as the probability distribution. You can use the following results. Oh, this looks like Riemann zeta function. Nice. Okay, sum of the harmonic series is divergent. That's true. Sum of 1 over m squared. In fact, I can tell you exactly that's pi squared over 6. That's called the Bessel problem. You can look it up. And the sum of 1 to m cubed is a transcendental number, but it is known to be approximately that. Okay. It's also known as Arpetti's constant. Find the value of A. Okay, this one should be quite simple. We want the sum of all probabilities to be equals to 1. So we are taking basically the sum of 1 over m cubed times A equals to 1. So therefore A is just equals to 1 divided by the sum of 1 to m cubed all the way to infinity. So 1.2021. Okay, that's it. And you'll get, and of course you'll get 0.83188, which is 0.832. But we'll keep the value of 0.83188 for later. Find expectation of x. Why you cannot calculate variance of x. Okay, expectation of x is, so you're going to sum up A, so you will take m divided by m squared for each one. M divided by m cubed, sorry. Then you multiply by A. So it's A times the sum of uh, m equals to 1, and we can take on all the values, so infinity of 1 over m squared, and you will get 0.832, or rather 83188 times 1.6449. Okay, whatever this is, which is 1.3684, which is 1.37. Okay, variance of x would be expectation of x squared minus expectation of x squared. But what is the expectation of x squared? This would be A times the sum from m to n equals 1 to infinity of 1 over m, which does not exist. It's a divergent series. In fact, the divergence can be proved using H2 maths. I think somebody has done a Riemann sum with the ln function before. So yeah, you can actually prove it with H2 maths, but we don't need to. Find probability x greater than or equals to 2 given that x is less than or equals to 15. Okay, there's actually two ways to do this, but the way that I used was probability 2 less than or equals to x less than or equals to 15 divide by probability of x less than or equals to 15. Because if you're given that it's less than or equals to 15, find the probability that is greater than or equals to 2. You just need to consider every value from 2 to 15. The other possibility is you take you find the probability that is less than or equals to 15, then you take 1 minus the probability that is 1. Yeah. Then you multiply those two together. Also can. This gives you the sum, m equals to 15 of, so this is actually actually the a's will cancel out, but you can do a sum over 1 over m cube. Actually no, the a was inside. A over m cube divide by the sum m equals to 1 up to 15. Oh my god. To 15 a over m cube, which is 0.167. Okay, and I'm going to leave it at that because we don't need to use that result later. M1 generates 10 numbers. The random variable y is the number of times number 3 occurs. Assume the numbers generated by the program are independent of one another. Find the probability that y is greater than 2. Okay. So what is the probability that x is 3, first of all? Well, you can easily calculate it. It's 0.030180. Okay. So y is already defined, but we can see that y actually follows the binomial distribution because either a number is 3 or it's not, right? So we take 10 and we take 0. Sorry. Yes, correct. And then the probability of success is 0.030810. Okay? So then you can find py equals to 2 accordingly. Y greater than 2 is the same as 1 minus probability that y is less than or equals to 1, or rather y is less than or equals to 2. Okay, and this gives you, you just use binomial CDF for this, 0.0298. Okay. Finally, probability that x1 plus y is equals to 3. Okay, be careful with this one, because now Daman Hai actually had a different solution. My solution was to define a new variable, and I'll explain why. I have x1 as my first number, so y is the number of times I'm counting. Y is the number of times that I am counting 3 among the 10 numbers. So either x1 is 1 and y is 2, meaning that I get 2 3s out of the 9 remaining numbers, or I have probability that x1 is 2 and y is 1, meaning that I have a single 3 among my 9 remaining numbers. So what I do is I define y prime to be binomial 9 trials with the same probability. Okay, although I think what I did is in essence the same as Daman Hai, but it's a slightly different kind of way of seeing it. Okay, y prime is binomial of this, so there's only 2 cases, because once again, if you find x1 is 3, then y has to be 0, right? But x1 itself is 3, so that's obviously a contradiction. So the probability that you have x1 equals to 1, because the next 9 numbers are independent of the first number, you can do px1 equals to 1 and py prime is equals to 2. Okay, plus p x1 equals to 2 times, once again, the 9 numbers after the first one are all independent of the first number, so you can do y equals to 1 here. Okay, and you can calculate this. You will get 0.022835 plus 0.022448, which is 0.0453 3SF. Okay, so that will be it for Daman Hai stats. I hope I'll be able to get up the ACJC 2021 prelim stats tomorrow. Although I will take note that there's no correlation question for that paper because it was 2021, it was a common last topic, so it wasn't tested. Okay, so that's all for now, and all the best everyone for the paper 2 on Friday. We've all got this together. Yeah, see you guys real soon.